Use the Pythagorean theorem to find the distance between point x and y. So what we're doing here is we're going to be finding the distance between x and y. So we're going to use the Pythagorean theorem. Pythagorean theorem states a squared plus b squared equals c squared. And the c is represented by this distance, this slant distance. You can't count those points. So that's why it's important to use either distance or the Pythagorean theorem. So here, let's start with A, the horizontal distance. So that means it's going to be from this point all the way to the point it reaches here, until it reaches the end of the second point. Then, from that point, you're going to find B, the vertical distance from here all the way down here. So one of the easiest ways to do it is skip count. Just make sure that you don't count incorrectly. That's why it's kind of good to always check your work with the absolute value, ruler apostolic, but from here. So we start right here. You don't count that point. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We have 12 units for our A, 12 squared. How do I know that? Well, A is the absolute value of x2 minus x1. Our x is at, let's just say that's sub 1, -5. Oh, I guess x2 at this point, doesn't matter. And then right here, this one's at 1, 2, 3, 4, 5, 6, 7. Yeah, look at that. We get -12. So, yeah, we did it right. Good. You can skip count here again. 0, 1, 2, 3, 4, 5, 6, 7, 8. Again, you don't count this point. 0, 1, 2, 3, 4, 5, 6, 7, 8. Plus 8 squared equals c squared. So from here, start going about it. Just check our work as well. I want to make sure I'm doing this right. So let's check our work. B is equal to the absolute value of y sub 2 minus y sub 1. So this, we called x2 last time, so we'll just call it y2. So down here is about 6. Yep. So this is equal to -6. And up here, that's represented by a positive 2 minus 2. So then you get absolute value of -8. You get 8. So good, we did it right. Alright, let's just start simplifying this. 12 times 12, 144. 8 times 8, 64. C squared. 144 plus 64, 208. 208 equals c squared. Then to get the c squared, get the c by itself, you square it. C is equal to 14.42. Let's see if we can simplify this 14, or this square root 208. Let's see if we can simplify that. So square root 208, we're going to break this down using the factor tree. Yeah. 208 divided by 2, 104. Then you can break 104 down by 2, you get 52. Break down 52 by 2, 26. Divide that by 2, 2 and 13. Circle all the prime numbers. We see that we have them all. We're done. So now, this is the same as saying 1, 2, 3, 4. Oops, why am I doing a square root within a square root? We don't want to do that mess. Alright, we have 2 times 2 times 2 times 2 times 13. With a square root, we're just going to be taking out all the prime numbers within it that form, perfect squares. Well, what's 2 times 2? It's 4. What's the square root of 4? 2. So we're going to pull out our first pair. We're going to pull out our second pair. 13 doesn't have a pair, so it's stuck at home, so it stays under the bar. So 208 could be simplified to 2 times 2, square root of 13. 2 times 2 is 4. 4 square root of 13. So our answer could be 4 square root of 13 or 14.42. Alright, that's it.